So hello, I'm Mélanie and I'm here to talk about Sirius. So what is Sirius? Sirius is an Eclipse project which allows you to create easily your own graphical modeling workbench based on your domain-specific language. Sirius is a very active project. It is part of the release train, and so we release one major version each year in June, and the rest of the year we release the maintenance version every 2 months. There are more than 10 committers actively working on Sirius. Sirius is fully compliant with the other components of the Eclipse modeling ecosystem, and you use Sirius to create graphical workbenches for any DSL defined with EMF. Sirius can be integrated with CDO to store your model in a database and so provide a real-time collaborative solution. Sirius uses AQL to query the model. Ecore Tools is based on Sirius and provides a graphical environment to create EMF models. And you can combine textual editor based on Xtext and graphical editor based on Sirius in the same workbench, and allows your users to edit the model thanks to textual or graphical editors, depending on what fits the best their needs. You can integrate also Sirius with Axeleo to generate some text from your model. And you can also integrate EMF Compare to compare and merge models. So, what are the principles of Sirius? First, you define a meta model thanks to EMF. Then, you provide a Sirius configuration to specify the mappings between the different concepts of your DSL and how they should be represented graphically. And it results in a graphical modeler dedicated to your DSL. The Sirius specifier is in charge of creating the meta model and the Sirius configuration, and the final result is a workbench dedicated to your end users' specific needs and to their own language. So first I will do a demo. Okay. First I will just demonstrate the kind of modeler you can create with Sirius. So imagine that I have to create a graphical workbench for engineers which have to design robots. This is a modeler based on Sirius. What you see here is on the left you will have a model explorer, and on the right you will have a kind of dashboard that helps you to manage your semantic model and your different representation. You can create new representation, delete some representation, or just navigate to existing representation. So here I am opening a representation. This representation shows two different systems, and for each system you will have some data sources and some processors and some engine. Imagine that I want to create a new data source in my system, and I will just rename it front camera. You see that when I did the change of the name, the icon used to represent the data source changed because the SVG side is based on the name, and as I used the word camera, it takes the corresponding SVG. Now I can create also a flow between my data source and my processor. And as the colors are awful, you can't see it too much thing, but this is orange. And before it was blue. And so the GPU processor goes to orange because the capacity does not fit the volume. So I decided to change the capacity to 12. And now, when I say the capacity, of my GPU. Oh, it's horrible. I need the colors. Okay, so normally, if I change the capacity of my, sorry, this one. If I change the capacity of my GPU, then my GPU goes back to the blue normal color. Now imagine that my front camera goes from SD to HD quality, so the volume changed also, So I'll update the volume of my front camera to 10. And you see that the size of the camera, of the icon change also. My GPU is again orange because the capacity is not good enough, so I have to increase it again. And you see that the icon of the GPU also is larger, and this allows the end users to simply identify which are the large processors. After this, I can also activate some layers. So I will activate it. I can't find it. Okay. I will activate the temperature layer. And now you see that the form are changing, the color are changing. And the first thing you can notice is that my system is now has a new label, which also shows the temperature. And the color of the system also changed to be red because the system is too hot. So what can I do also is, by activating the layer, I have also two new icons on my diagram, which represent fans. And I have also, by activating a layer, I have also a new tool here. So I'm able to add a new fan, and my system is okay again. I can deactivate the temperature layer, and as you see, I'm able to activate some others. So you see that with Sirius you can create diagrams, but you can also create some other kind of representations. I have two other different representations that I created. I'm able to create cross tables. This one is representing the processors, and I can't see what it is, in the data sources. And I'm also able to create some other kind of representation, like a table, for example. This one is just showing all the different processors existing on my system. You can see that if I put a diagram here and the table, all this is working on the same semantic model. And so if I am updating the capacity of my GPU to 12 again, when I save, the representation, the diagram is in the same time update and modified simultaneously. What's that? Okay. So, how do I use Sirius to create this kind of graphical designer? The graphical editors are defined by a model which defines the complete structure of the modeling workbench, its behavior, and all the edition and navigation tools. This description of a Sirius modeling workbench is dynamically interpreted by a runtime within the Eclipse IDE. In the end, your final users will only see the end-user workbench and not the configuration. As I said, the workbench structure is defined entirely in the Sirius configuration. Sirius provides, by default, for each workbench a model explorer and a dashboard editor, which allows to navigate into the model, create new semantic models, and new representations. A graphical designer provides viewpoints adapted to the user's role or activity, and in the end, the viewpoints are visible in the model explorer and from the dashboard. Each viewpoint corresponds to a set of representations, diagrams, tables, matrices, or trees, which can be completely customized. The end user can manage the representation from the dashboard editor, and the definition of a new diagram kind in the Sirius configuration results in a new kind of diagram available for the end user. So, as I show in my demonstration, it is possible to provide diagrams, but also tables and matrices. And each diagram provides default and optional layers. These layers are activated from the diagram toolbar. And the layers can add graphical elements on diagrams, but also provide new tools in the palette. The main point of the Sirius configuration is to specify the mappings. different kind of mappings can be defined, like node, container, or edges. And if you go back to my example, the processors are defined thanks to a node mapping. And what it means is that when I define a mapping in my Sirius configuration, I first have to declare on which kind of elements of my metamodel this mapping applies. And in this example, I'm specified that the processor will be mapped to the CPU blue image. Then I have to specify how I find this kind of elements from my model. Here, I am telling to Sirius that all the processors which are system elements must be represented thanks to the blue square CPU image. So it is also possible to define containers, which will allow us to represent containment relation. And here in my system contains different kind of elements. So we have processors, data source, and fans. And finally, the Sirius configuration allows also to specify, for example, edges. So if we go back to our example, now we will have a look at what it looks to create a Sirius specification. So this was my example. This is my Sirius project. All the configuration is defined in only one file, which name is .design. Here it's a flow.design. And what we see is that there is just one description for each kind of representation. So I have created a diagram which is named topographies, and I have my matrix and then my table. If we go inside my diagram, then you see that we have different layers. The default ones and the temperature one I show you. And under my layer, I have different kind of mapping. The one which represents my data sources. There is also the one for my system. If I have a look to the one for my system, I find that at the moment the system are represented thanks to a gradient with a light gray color. And if I just put this like it, I'm able to update dynamically the color. For example, this time I decided not to show this in light gray but in light blue. And when I save, you can see it because the colors are awful, but it is blue now. So you can see that defining your Sirius specification, you can show directly in live what your end workbench looks like. So it's really easy to iterate on your configuration to see what you want to do and to show to your customer if it looks is okay for them or not. Also, I'm able to change, for example, the representation of the label. Here, for the moment, I'm just showing the name of my system. I can add some other information. For example, now I want to show also the weight of my system. So as you can see, I'm using HQL language, and I have completion that allows me to find which are the good queries, which are the properties and the feature I want to use. And so at that moment, I decided to use the weight. And I can add also some more textual static text. When I save, you can see that automatically my subsystem changed its label and had the weight. What I could do also is, maybe I want to add a fan directly in this representation. So I can create a new mapping. To create new mapping, you can just right-click on this container you want to add a new element, and you have three different kind of elements you can add. The border nodes, that this kind of mapping will put some nodes around your container. Then you can describe subnodes, which are kind of which are just a simple element. And then you can have container, which would contain also other elements. So this ifan would be a subnode. This would be my fan. And what I want to do is that this kind of element will be mapped to the flow fan element from my meta model. Okay, so now I need to add a style, and I decided to use just a simple style, which is a gray square. Okay, when I save, you see that I have new elements appearing directly in my diagram, which are representing my fan. I know that my fan has no name label. By default, Sirius proposing to add a name, but my fan could contain, for example, a speed. So I want to show the speed of my fan as label inside my new form. I think that's all for this demo. No, also I'm able to create some tools in my palette. So how could I do this? It's really simple with Sirius. I create a new section to contain all the tools, and in this section you can find all the tools that are inside the palette, like for example the one allowing to create new processors. And if we have a look to this tool, we describe the behavior of the tool thanks to a really simple language. When I use this tool in my diagram, it means that in my semantic model I will create a new kind of element which will be a processor, and I will set by default some value to this new processor. For example, I'm just computing the name. The name would be the processor rod plus the number of elements it already exists, like the number of processors already existing. And I'm also setting the status to active. So in this sample, this is a small sample, and I show you that it is possible to create diagram, table, and matrix. But thanks to Sirius, it is also possible to define trees. You can also define sequence diagrams and properties view. So if we have a look at the robots designer game, you see that if you use just EMF, by default you will have this kind of properties views, this kind of table, this kind of terrible properties view. When you have to use it all the day, when you're an end user, it's not possible. By default, Sirius will provide a properties view for you, which looks better, I think. What we do is that we provide some rules to compute your meta model, and from your meta model and from the type of your properties in your meta model, we will propose a good widget according to the type of your properties. So, for example, string would be represented thanks to a text widget. Some references, if we have a look to this one, the references would be represented thanks to a table and with some buttons. And how do we do this? In fact, you can define your viewpoints with your representation, and you can define also some properties. I'm able to import the default properties rules we create. So if you have a look to the default property views, first we define a page. The page will be the main page you see here. And in this page you will have some groups. Here we have just one group. And what we do is, for each type of element we find in your meta model, we are associating to your element a widget. So here it is a text widget for a string. Here a multiple string, the boolean. And if you want to update this or just create another properties views and a new page, you can simply do it exactly in the same spirit what we do for the diagrams. By adding to the properties view, you are able to add new page, new group, and for a group you are able to create new widgets, and we have some widgets available like text, checkbox, radio, select, and reference. And we have also the ability to create some custom widget, and you can just put the custom widget you want you designed with SWT. Okay. So Sirius provides many things, and you can use other part of, you can use also some elements coming from another project, which is also an Eclipse modeling project, which name is Amalgam. And this project allows you to integrate, for example, an activity explorer in your Sirius workbench, and this will help your user by guiding him to, and you can provide, thanks to his activity explorer, some methodology. You can also use another component coming from Amalgam, which is the contextual explorer, and this one allows your end user to view the impacts of an element in his model, for example, which elements reference it and which elements it references. What I want you to understand is that Sirius is extensible in many ways. You can call Java code to manage, for example, the semantic model easily, but you can also use Java code to automate some actions, or for instance, to provide a specific layout. Sirius provides also many extension points to customize the default behavior. You can provide custom dialogues, style, arrangeable strategy, you can extend the tab bar, or even you can create also custom widgets. But you can also define new kinds of representations if diagrams, sequence diagram, tables, trees, and matrix does not fit your needs. You can create new one. And also, if you don't want to use AQL, you can use another new query language. So if you want to see what you can do with Sirius, you can have a look at the gallery available on Sirius website. There are lots of examples. And we're providing also another section on the website, which name is Lab. And on this section, you will find also another experimental component, which allows us to animate the Sirius-based modelers. Finally, remember that you have not to choose between textual and graphical editors. Both can work together. Cedric from Obeo and Jan from TypeSox will give a talk this week to explain what you can do and what you should take care of to mix Xtext and Sirius editors. And if you want to get started with Sirius, all the documentation and tutorials are available on the Sirius website, and you can go to the Obeo GitHub account to find ready-to-use open source modelers based on Sirius. For example, we have one which name is UML Designer, and this one is a UML modeler based on Sirius. You will find there are many concrete examples and lots of best practices about Sirius. To be sure to get all you need to start to work with Sirius, we are providing an all-in-one free bundle named Obeo Designer Community Edition. And we provide also another license bundle named Team Edition, which provides what you will need to create Sirius modeler based on CDO to provide real-time collaborative edition to your end users. When you are using Sirius, remember that we are here for you, and we will be really happy to answer your questions on the forum this week at our booth. And so do not hesitate also to give us feedback. As I said, we are actively working on Sirius, so you can make your voice heard and speak up and fill enhancements in the Sirius bug tracker. We would be really happy with that. Finally, remember that Sirius is visual. You can create diagrams, tables, trees, and even properties views. It is declarative. There is no code generation involved. Everything is interpreted at runtime. And the most important, Sirius is easy. You will get your own modeling workbench in hours. There are more talks about Sirius during EclipseCon. There is one tomorrow about UX I will do, and also another one about Sirius and Xtext. I already mentioned this one. There is another one about M2Doc, which is a new open source project which allows you to generate Word document from a model, and this project easily integrates the diagrams you developed with Sirius. There is also an example of a workbench developed with Sirius, which allows to create a process studio. And finally, a last one about the integration of Sirius with CDO to get live collaboration on graphical models. If you are interested in Sirius, be sure to be with us the 9th of November. We're organizing a one-day event all about Sirius. The program is available, it is free, it is in Paris, and you just have to register on the Sirius website, on the SiriusCon website, and Sirius website also. Thanks. If you have any question, I would be happy to answer. You have any question? No? Okay. I'm around if you have questions, do not hesitate. Thanks.